So we've essentially got a vocabulary lesson for 3.3. Nothing we've actually done is different. It's about reading it. So function notation. Notation just means essentially a different way of writing something, keeping track of information. A way of representing functions. All right, it's just a new way of representing things. If f is a function and x is in its domain, so remember domain is the x values, the things we plug in, f of x represents the output when you use x as the input. So in this situation, we don't treat f as a variable, we treat it as a notation. One of these should be very familiar to you, y equals mx plus b. The other one is function notation that does the same thing. So it's the only thing that has changed. Y represents the output, f of x represents the output. Okay? This does not mean f times x, not f times x. Okay, it is saying f of x. I'm going to write that out. F of x. Function of x. Okay. This does not mean multiplication like we would normally consider it in math. It's a different way of writing, hey, this is the output. Hey, this is the output. These represent the same information. Here we've got our first quick example. Evaluate the function f of x equals negative 4x plus 7 when x equals 2 and x equals negative 2. This means input, plug it in for x, and we want to find the output. When things are written in function notation, the intent is for you not to have to do algebra steps. The intent is for it to be organized so there's a clear input and a clear output. So the way we write this is, what are we replacing x with? 2. Okay? This doesn't mean we do any math. This doesn't mean I do f times 2. This is just a reminder what we plugged in as an input. Equals negative 4 times 2 plus 7. I will not do anything over here. This stays the same. This is going to be part of our answer. Instead of y equals a number, it's f of 2 equals a number, and the f of 2 reminds us what we plugged in to get that answer. So we just do our work over here. Order of operations says to multiply first. That's negative 8. Negative 4 times 2. And we add negative 8 plus 7 is negative 1. And so we have our answer. F of 2, the function when I plugged in 2, equals negative 1. So this is the output. This is the input. That makes an ordered pair. 2 comma negative 1 if we wanted to graph. Okay? So I wouldn't expect an ordered pair as an answer for this. I would expect this as the answer. F of 2 equals negative 1. Let's do the other side. Now these have nothing to do with each other. They're just using the same equation. So now I do f of negative 2 equals negative 4 times negative 2 plus 7. I only do my work on this side. This does not mean f times negative 2. So I'll start by multiplying. Negative 4 times negative 2 is positive 8. 8 plus 7 is 15. And that's my answer. F of negative 2 equals 15. Again, I could write that as an ordered pair. Negative 2 comma 15. And plot the point. But right now we're just trying to find the evaluated answer. So this reminds us of our input. The result, when everything's simplified, is our output. Okay? So it really is like y equals mx plus b when you have a number to plug in for x. There shouldn't be any algebra work to do. Here's another little part of that literacy reading the new situation type thing. Here, F represents the temperature. T represents how many hours after 6 a.m. So we're supposed to explain these. T is what gets plugged in. Here, a 0 was plugged in. So 0 hours after 6 a.m. is still 6 a.m. 6 a.m. The output is the temperature is 58 degrees. Next one, 6 hours after 6 a.m., that's 12 p.m. or noon. And they don't tell us the degrees. They say N. Okay, but that's all right. If that's the output and they just give us a variable, we just have to read it with the variable. Here, neither of them are outputs. It's just comparing based on inputs. So if this temperature is bigger because the alligator is eating it, this side's warmer. This side's colder. So 3 hours later, which is 9 a.m., 9 a.m. is colder or has a smaller temperature than 9 hours later, which should be 3 p.m. Okay? So I'm getting these times by just adding the input number to 6 a.m. And then whatever's on the other side of the equal sign should be the temperature, but in the third problem, we never compare a temperature. We know that the outputs can be compared. 9 a.m. is colder, but we don't have any specific temperatures for that one. So try to read and understand what I did here. I tried to explain myself, but this is something I'd almost expect you to come to class with questions on. So here's a different type of function notation problem where we will actually have to do algebra steps. Don't be concerned that it's h of x instead of f of x now. That's fine. What you need to know going into like the ACT, because they're going to throw a lot of this function notation at you, is just that this is function notation. Okay? That's all you need to know. If there's a letter with parentheses and another letter, it's function notation. All right? So here they're saying the output is -7. So if I reword this question, just to help you read it the way I kind of read it, find x when y equals -7. For this equation, y equals 2/3 x minus 5. I think you guys can handle that no problem. You know to plug y in for y. You need to read this the same way. All right? We handle it the same exact way. So I'm going to rewrite my equation, -7 equals 2/3 x minus 5, and solve. Add 5 to both sides to get the 5 off over here. -2 equals 2/3 x. Now, a simple way to handle fractions, some of you guys struggled with this, so I'm just going to go through a little strategy, is if you multiply everything by the denominator of a fraction, anything that had the denominator cancels out with it. Anything that didn't actually gets multiplied. This is a useful skill going into like an advanced algebra class too. So 3 times -2 is -6. The 3 canceled with that 3, so it's just 2x now. So there's a little strategy for you. Got the shadow in the way. Maybe I can block that a little bit. Not without getting in the camera though, huh? So then we would divide by 2, and my answer would be -3. Here, I'm going to work over to the side. Get away from that glare. Is that enough space? I'd have to go all the way over, huh? Anyway, where I'm at is -6 equals 2x. Then I'm dividing by 2 and getting -3 equals x for my answer. So that's where I went. All right, so it just turns into a normal algebra problem. Again, it's just an interpretation thing. Graphing the function is just like graphing y equals mx plus b. What they want you to do is they want you to make an xy table. Instead of y, you write f of x, where you plug in numbers. I suppose we can do 1 or 2. But I really think this is a waste of time because I think there's better ways for us to approach this that'll help you further along in the future. If I plug 0 in for x, 2 times 0 is 0 plus 5 is 5. If I plug 1 in for x, 2 times 1 is 2, plus 5 is 7. Cool. 0 comma 5, 1 comma 7. I can count. 1 comma 7. Yay. All right? I don't like that though. When we have a simple equation like this to analyze, I want to jump right into the y equals mx plus b train of thought. B represents the y-intercept. So what you do is you write a point, 0, comma, b. Now for us, we have plus 5, so b is a positive 5. Hey, look, the point 0, comma 5. For me, my m is 2 over 1. You can turn any whole number into a fraction by sticking a 1 under it. Positive numbers on top are up, negative ones would be down, so up 2. The bottom, positive numbers are right, negative numbers would be left, right 1. So up 2, right 1. And we can go backwards. Down 2, left 1 works the same way. Down 2, left 1 again, and it forms a line. I really prefer this type of thinking. I hope you were doing this in 8th grade or at least got introduced to it, but we're going to spend a lot of time doing that. We'll use those tables of values to check our answers. We'll use those table of values when we get to exponential functions, but we will not rely on them too heavily for this type of thing. I want us to be able to break down y-intercept and slope more than I want us to be able to plug and chug some numbers.